Hey class, Mr. Mudin here with another video to help you with your homework. Once again, a calculus problem dealing with the area between two curves. So here we have a pair of trigonometric functions. Those are our boundary functions here. And we have sort of an arbitrary right bound of 3 pi over 4 and a sensible left bound of negative pi. And we're looking for the area of the shaded region. So we have two regions here. We have this space and we have this space. One tricky part about this is to figure out precisely which function is the upper bound and which one is the lower bound, and if that hands off or switches as you go from one region to the next. So keep in mind that the sine function looks like this for its first period. So it starts at 0, it increases, and then it goes to the wave motion, as you can see there. So with that in mind, since one of our functions is sine of x, you'll notice that that first part of the period is happening right here. So if you follow the smooth differentiable curve, this would be sine of x right there. And the reflection negative sine of x is the other curve. That's going to be the other function right here. And indeed, if you look carefully, you do have two regions, and they do have different upper and lower boundaries. For the first region here, the upper boundary is green, which is negative sine of x, and the lower boundary is red, which is sine of x. And in the second region, the sort of truncated one, the upper boundary is sine and the bottom boundary is negative sine. So that's going to require a little bit of care as we do our calculations. So let's find the area of this first region, which I used yellow here, which is hard to see, so I'll just use, I don't know, maybe I'll just use black for this first region, which I'll call region A. Region A has an area equal to the sum of rectangles, each of which have a height, or rather, that are summed between negative pi and 0. Each of them have a rectangular height that is dependent upon the two functions, and the upper function, as we just stated, was negative sine of x, which is the green function, minus the bottom function, which is the red function, or another sine of x. So this minus comes from the idea of difference of area between two curves, and the other minus, of course, was built in. So there's my height, dx is my width. So there's the area of infinite rectangles. This can be simplified significantly, and if I combine like terms, I get negative 2 sine of x. One of the properties of definite integrals is that you can pop a constant multiple out. So what I'm going to do is I'm going to bring this one on the outside because I feel like it'll get in the way of some calculations. So I'm just going to pop that out here and just focus on the variable bits rather than the constant bits. So that gives me sine of x dx. So what has a derivative of sine? Let's see, it's going to be cosine of some kind, but cosine's derivative is negative sine. So the antiderivative of sine must therefore be negative cosine. And this is being evaluated from negative pi to 0. So let's see if I can bring in some trig review while we're at it. Do this without a calculator. Got negative 2 out here. I'm going to plug in my upper and lower bounds. Be very careful with the parentheses here. Negative cosine of my upper bound of 0 minus the same function evaluated at negative pi. So negative cosine is my antiderivative function, and that's being evaluated at negative pi. I'll give myself a bit more room. At negative pi. So how do we get these without a calculator? Well, let's think back to our unit circle, where this is 0 degrees or radians, and of course making the full 2 pi. 0, of course, is 0, so we don't have to move our rotating arm at all here. Cosine is adjacent hypotenuse, and there's no circle here really, or sorry, there's no triangle here really, but the x value would be adjacent to our theta angle, and the x coordinate of that point would be 1. So this would be 1 right here, but of course you have the negative, so that's going to be negative 1. I'm going to go ahead and make these two into what they're going to become, which is positive, and then just deal with the trig portion, cosine of negative pi. Well, negative pi means we work in the opposite direction, so we're rotating clockwise, but that's actually going to give me the very same amount had I not known that. In any case, there's my negative pi rotation. X value or cosine is still 1, but this time it's a negative 1. So I have this positive here from this signage, SIGN signage, and I have this negative 1 from the cosine of negative pi. Of course, I have this negative 2 lurking on the outside, and it's about to be dealt with. Let's use blue here. Negative 1 plus negative 1 is negative 2 times negative 2 is an area of 4. Now, signed area under a curve can sometimes be negative, so to speak. However, area between curves is always going to be positive. So if you get a negative result here, it's a clue that something has gone horribly wrong. The reason it's always going to be positive is top minus bottom, no matter what kind of numbers those are. In case here one's positive, one's negative for most of this interval, you're always going to get a positive result because that's how we measure distance. Is a bigger number minus the smaller number. So this area here is 4. This area would also be 4 were it not for this sort of arbitrary bound of 3 pi over 4. So let's see if we can find the remaining space. Not sure what that was. Let me paste in the picture. Sorry for that. Peek behind the scenes. Okay, so we're looking for now this region right here, which, if you recall, this is our sine wave, which I think I had in red, and this is our negative sine wave, which I have here in green. I don't know what the original colors were. So to find the area of this region, which I'll call region B, that's going to be, the area of B is the sum of rectangles from 0 up to our handoff or our ending point of 3 pi over 4. The upper function is my red function of sine of x minus my lower function, which is negative sine of x. So be careful with your, again, SIGN signs here. Adding like terms will give me 0 to 3 pi over 4 of 2 sine of x, height, dx width. I'm going to factor the 2 out once again, just to simplify my calculations. And I have sine of x, dx. Antiderivative of sine remains negative cosine of x. Evaluated at 0 and 3 pi over 4. So plugging these in, negative cosine of 3 pi over 4 minus, bracket this, negative cosine of 0, bracket that. Okay. Once again, see if we can review some trig while we're at it. 3 pi over 4 is 45 degrees because pi over 2 is 90 and pi is 180. So if pi over 2 is 45, then 3 pi over 4 is simply 3 rotations of 45. So 45, another 45, that's 90, and then that brings me right there. So there's my 3 pi over 4 rotation, 3/4 of the way of a half circle pi. So let's see. One thing to remember for the pi over 4 values in the unit circle, the numbers for the coordinates are all root of 2 over 2 from your special right triangles of 45 degrees. So if you think about the coordinates in this quadrant, the x value has to be negative. I don't know if you can see that because it's kind of tiny. X value must be negative and the y value has to be positive in order to live in this quadrant. So there's our coordinates. Our cosine is adjacent hypotenuse from SOHCAHTOA, from a reference angle right there of 45. So adjacent hypotenuse would be this negative length. Long story short, this is going to be negative square root of 2 over 2. However, there is also a negative from the antiderivative, so that's going to be right there. So this is going to become a positive. I have a positive here as well. Cosine of 0 is, as we saw previously, 1. So that's going to be 1 right there. So that's a positive root 2 over 2. I'm going to go ahead and distribute the 2's, the 2 here rather, on the outside. And that's going to give me a cancellation here. That's going to give me root 2 plus 2 times 1 famously is 2. So this area is 2 plus the root of 2. So let me see if I can fill that in. We had an area for region A to be 4, and here the area is 2 plus the root of 2. The area here was 4. Combine them together, and you have the full area of 6 plus the root of 2. Hope this helps.